Here are 10 interesting facts about the Milky Way galaxy, otherwise known as your home. The galaxy itself is warped. The Milky Way galaxy is a disk about 120,000 light years across, with a central bulge that has a diameter of 12,000 light years. The disk is far from perfectly flat though, as can be seen in the actual picture. Now you might wonder what actually warped the galaxy. Two of the galaxy's neighbours, the large and small Magellanic Clouds, have been pulling on the dark matter in the Milky Way like a game of galactic tug-of-war. The tugging sets up a sort of oscillating frequency that pulls on the hydrogen gas, which, to be fair, there is plenty of in the actual Milky Way. The galaxy itself has a halo, but you can't actually see it. The Milky Way has a halo of dark matter that makes up over 90% of its mass. Yes, actually 90%. That means that all that you can see with your naked eye telescope makes up less than 10% of the mass of the Milky Way. Now, it doesn't have a halo like those little cartoon characters that die, sprout wings and play harp in the clouds. The halo is actually invisible, although we know it exists by running simulations of what the Milky Way galaxy would look like and how fast stars inside the galaxy's disk orbit the centre. The heavier it is, the faster they should be orbiting. If you assume that the galaxy is made up only of matter that we can see, then you get a rotation rate for the stars that is well below what it should be. So the rest is made up of what is elusively called dark matter, or matter that only interacts gravitationally with normal matter. The Milky Way galaxy has over 200 billion stars, which seems like a heck of a lot, but actually the Milky Way galaxy is, in terms of star composition and middleweight, the largest known, which is IC1101, has over 100 trillion stars, and other large galaxies can have more than 1 trillion stars. Smaller galaxies like the aforementioned Large Magellanic Cloud have about 10 billion stars. The Milky Way has, as I say, over 200 billion, and it could be as much as 400 billion. But when you look up into the night sky, the most you can see from any one point on Earth is about 2,500. We aren't stuck with this many stars forever though, because the Milky Way is constantly losing stars through supernova and producing stars. It actually nets probably roughly 7 stars per year. The Milky Way galaxy is very dusty and very gassy. You may not think so by looking at it, but the Milky Way is just chock-a-block full of dust and gas. And when I mean full, I mean about 6,000 light years into the disk of our own galaxy in the visible spectrum, we can only see that far. And the galaxy is about 100,000 light years across, so we can literally see just over 1/20th because of the sheer amount of gas and dust. And the gas and dust makes up a whopping 10 to 15% of the normal matter in the galaxy. So before we had 10% of matter, so if you were to cut that down, 10% of that is actually gas and dust, and the remainder is stars. The thickness of the dust deflects visible light, as is explained in my other blog, but infrared light can pass through the dust, which makes infrared telescopes like the Spitzer Space Telescope extremely valuable tools in mapping and studying the galaxy. Spitzer can peer through the dust to give us extraordinary clear views of what is going on at the heart of the galaxy and in star-forming regions. Our Milky Way galaxy is actually made up of other galaxies. It wasn't always as it is today, a beautiful barred spiral. It became its current size and shape by eating up other galaxies. It's still doing so today. The Canis Major Dwarf Galaxy is the closest galaxy to the Milky Way because its stars are currently being added to the Milky Way's disk, and our galaxy has consumed others in its long history, such as the Sagittarius Dwarf Galaxy. That could well be to do with gravity, as in gravity is responsible for attracting everything to everything else. It attracts matter to other matter. And so we are on a collision course with Andromeda. Now, every picture you've ever seen of the Milky Way from above is either another galaxy or an artist's interpretation. We've never been able to take a photograph of our own galaxy as of yet. The furthest man-made object away from Earth at the minute is Voyager 1 and Voyager 2, which are just outside of the Kuiper Belt, or the Oort cloud, I should say now. It could be a hell of a long time before we wait if they ever make it outside of the Milky Way, in which case they could well take a picture, but it will take a long time for us to receive it. Now, We are inside the galactic disk, about 26,000 light years from the galactic centre. You can see on the diagram where the sun is marked on Orion's arm. This means that any pretty pictures you do see are another galaxy, or have been drawn by a very talented artist based upon rough images. If we were to look at other galaxies, we could garner probably a rough idea as to what our galaxy does look like. There is a massive black hole at the centre. It is huge. Most galaxies do have a supermassive black hole at the centre. Ours is no exception. The centre of our galaxy is actually called Sagittarius A, and it houses a black hole with a mass of 40,000 suns that is 14 million miles across, which is probably about the size of the orbit of Mercury around the sun. But that's just the black hole itself. All of the mass trying to get into the black hole, called the accretion disk, because that's what the black hole is doing. It is accreting matter, it is gathering it together, forms a disk that has a mass of 4 million suns and would fit inside the orbit of the Earth. Though like other black holes, Sagittarius A tries to consume anything that happens to be nearby. Star formation has been detected near the black hole itself. Our galaxy is almost as old as the universe itself. The most current estimate of the age of our universe is roughly about 13.75 billion years. Our Milky Way galaxy has been around for about 13.6 billion of those years, give or take 800 million years or so. The oldest stars in our Milky Way are found in globular clusters, and the age of the galaxy is determined by taking the age of these stars and then extrapolating the age of what preceded them. Though some of the constituents of the Milky Way have been around for a long time, the disk and bulbs themselves didn't form until about 10 to 12 billion years ago, and the bulbs may have formed earlier than the rest of the galaxy, and it probably did. As you probably know, things probably start from the inside and work their way outwards. Because there are that many galaxies in the known universe, it's part of the Virgo supercluster, which is a grouping of galaxies which are within 150 million light years of each other. As big as it is, the Milky Way is part of an even bigger structure called the supercluster. In between these superclusters are large voids of space, where any space travel would encounter very little in the way of galaxies or matter. Our close neighbours include, as I said before, the Large and Small Magellanic Clouds and the Andromeda Galaxy, which is the closest spiral galaxy to the Milky Way. And along with about 30 other galaxies, this group of galaxies make up what is called the local group. But as you get further out, that is, on the scale of hundreds of millions of light years, the Milky Way can be seen to be just a small part of this large group. And it's actually constantly on the move. It is not still. Nothing is still in the universe. Everything is moving, whether it be orbiting or rotating around something else. And it puts shame to anything from everyday life that one could compare its speed to. The Earth moves around the Sun around the Milky Way, and the Milky Way is part of the local group, which is moving relative to the cosmic microwave background radiation, which is the radiation left over from the Big Bang, which is a convenient reference point to us when determining the velocity of things in the universe. The local group is calculated to be moved relative to the cosmic microwave background radiation at 600 kilometers per second. That's 2.2 million kilometers per hour, which is very, very fast. And there's your facts. I'm sure if you want to look up any more, you could do. That's a rough guide to the Milky Way Galaxy, otherwise known as our home.